Hi guys, and welcome to another video. In today's video lesson, we're going to be looking at grade 10 maths, Euclidean geometry. We're going to be looking at the properties of a rhombus and also proving that the diagonals of a Parm, which is a parallelogram, bisect each other. And the question that we're going to be looking at is from the November 2017 paper 2. So let's get straight into it then. It says that KLMN is a rhombus with diagonals intersecting at O. LKM is equal to 34 degrees. So let's have a look at that. Now let's look at firstly, LKM is 34 degrees. Okay, now let's look at what are the properties of a rhombus. The properties of a rhombus are as follows. Remember that all sides of a rhombus are equal. Okay, that means the adjacent sides are all equal. What else do we know about a rhombus? Number 2. We know that the diagonals bisect each other at 90 degrees. So all these diagonals bisect each other at 90 degrees. And the third one is that the diagonals bisect equal angles. So what does that mean? It means that N1 is going to equal to N2, L1 equals to L2, and then that angle there, 34, that one is going to be 34 degrees there, and M1 is going to equal to M2. Now these are the most important properties that you need to know when it comes to a rhombus. Remember that a rhombus also has all the properties of a parallelogram, which means the diagonals bisect each other, right? So that's important for us to take note of. Now that we know the properties of a rhombus, let's answer the questions. Write down the size of O1. So where's O1? There's O1 over here. 90 degrees, right? So that's going to be 90 degrees, and we can write down diagonals bisect at 90 degrees. Diagonals of rhombus bisect at 90 degrees. So that will be 8.1. Let's write that down. 8.1. 0.1. So O1 equals to 90 degrees, and our reason will be diagonals of rhombus bisect at 90 degrees. Okay, so that should do. The next one is, it says calculate the size of L1. There's L1. Where's L1? There's L1 over here, right? What do you notice? You'll notice that this now is a triangle. So if that's 90 and that's 34, right? So it'll be 180 minus 90 plus 34. 90 plus 34 degrees, right? There's 90 degrees and 34. Remember, you must update your diagram because one thing leads to the next. 56 degrees. So now we can write that answer down there. 56 degrees. 56 degrees. Remember, diagonals of rhombus bisect each other. Okay, so L1, we're going to use sum of angles of triangle, and let's write down our solution. So we can now say for 8.1.2, let's write that down. 8.1.2 L1 equals to 180 degrees minus 90 plus, what we got there, 90 plus 34, 90 plus 34 degrees, sum of angles of triangle add up to 180 degrees, and we've already put that in our calculator. 180 minus 90 plus 34 is 56, so that's 56 degrees. And remember that we're constantly updating our diagram as we go on. Right, now the next question is calculate the size of KNM. KNM, where's KNM? Right there you can see now. KNM, this whole side over here, KNM. Now KNM, you can look at it like this here. See, these lines are parallel. The arrow on the line means that these lines are parallel. Okay, so if that's 56, that's also going to be 56. Okay, if that's 56, see this lines here, see parallel lines, alternate angles. If you look carefully, you'll be able to see that. See, there's a chair. right? Remember, we're looking for the Z shape, right? So you can write 56 degrees. But as I told you also earlier, that the properties of a rhombus, remember, it has all the same properties of a parallelogram. Therefore, the opposite angles are equal. So 56 plus 56 is going to give us 112. 56 plus 56, 112 degrees. So therefore, this angle here is going to be 112 degrees. Opposite angles equal. So let's go write that down. 8.1.3. So 8.1.3. We'll write down K and M. So we can write down K and M equals to 112 degrees. Opposite angles equal. Remember, because the rhombus has the exact same properties of a parallelogram. So opposite angles equal, opposite sides equal, diagonals bisect each other. Now let's go look at the next question. Now the next question is, given that PQRS is a parallelogram with diagonals PR and QS intersecting at M, they want us to prove that the diagonals bisect each other. Okay, so let us try and prove that the diagonals bisect each other. Okay, now if you go back to the work schedule, we are actually looking at this. The following proofs and theorems are examinable. So this is like today's lesson, what we're looking at, right? The opposite sides and angles of a parallelogram are equal. We must know the properties. The diagonals of the parallelogram bisect each other. So we're proving this theorem here. Now, let's have a look at it. And we also looked at the properties of a rhombus today. Remember that your job is to make sure that you tick off each one of these points in your work schedule to make sure that you are prepared for your exam. So let's go back now and look at it. So what we're going to write down. So if you look carefully, I want to prove that the diagonals PR and QS intersecting at M. So PR is this, and QM. Okay, so QS rather. So what I want to do is I want to prove that the diagonals bisect each other. So I want to prove that PM is equal to MR, say and I want to prove that QM is equal to MS. That's what it means to prove that the diagonals bisect each other. So what can we use here? Well, we can use congruency. Look at this triangle here. Okay, that's one triangle. And there's another one here. There you go. Okay, and what do we know? What do they tell us already? They already told us that PQRS is a parallelogram. What do we know about a parallelogram? We know that the opposite sides are equal, opposite sides are parallel, diagonals bisect each other. So they kind of already told us that the diagonals bisect each other, but we just want to prove it here. Okay, so we're going to use that fact. We're going to say PQ equals to RS and so on and so forth. We can say vertically opposite angles here. M1 is going to equal to M3. What else can we use here? Right, so we got a side, we got an angle, and we can use this one here. We can say P2 and R2 are equal. That will be alternate angles, and that is because, see, they gave us that these lines here are parallel. So we can now prove that these two triangles are congruent to each other, which would now mean that PM is going to equal to MR and QM equals to MS. Right, so let's go write those statements down for 4 marks. So let's start off by saying this is 8.2. So let's say 8.2 in triangle. Let's say PMQ. Let's write that down. PMQ. PMQ and triangle RMS. M is common. M1 equals to M2. And what else we got here? And what about Q and S? Q and S? Yep. Q and S will be equal to each other. Where is it here? We put a tick there. Right? Alternate angles. Okay, so we're all good. So naming of the triangles is quite important as well. I use this ticks and this crosses and circles just to visually so I can have a look at it. So my first statement will be, let's look at it. What I'll say, P2 equals to R2 alternate angles. So I'll say P2 equals to R2 alternate angles. And remember, now you must write the pair of parallel lines, and that is because PQ is parallel to RS. That is because PQ is parallel to RS. Statement number 2, I'm going to write that PQ and RS are equal. So I'm going to say PQ is equal to RS and opposite sides equal. Remember, because they told me that PQRS is a given, PQRS is a parallelogram. And then I'm going to write here M1 equals to M3. So third statement, I'm going to say M1 equals to M3, and that's going to be vertically opposite angles. Remember, vertically opposite angles are equal. Therefore, triangle PMQ is congruent to triangle RMS. And what do I have here? I got angle, I got a side, and I got another angle. So that's going to be angle, angle, side. That's one of the cases of congruency. Remember, congruency got 4 cases, right? Side, 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 angle, side, angle, angle, side, and right angle, hypotenuse, side. So we just so happen to use this one here, angle, angle, side. So what can we now conclude? We can now conclude that the diagonals bisect each other. So what we're going to say? We're going to say, therefore, PM equals to MR or RM. So PM equals to RM. Therefore, PM equals to RM. There's it here. See, PM and RM are equal. And what else you can write down? The next one is QM and MS. Let's go see where's that. QM and MS. There's it here. Right. There's QM there and there's MS there. So we can write that down. So QM and MS and QM equals to MS. So that's now proven. Okay. Therefore, we can say the diagonals bisect each other. Learners, if you haven't subscribed already, don't forget to subscribe to JL Maths. You can watch all videos in order of the work schedule on my website, which is freejlmaths.com. And you can like my Facebook page, Justin Lazarus Mathematics, and I'll catch you in the next video.